right, so welcome back. Yesterday we looked at the slope-intercept form, and we looked at the equation and how we can use the equation to determine slope and y-intercept. So if you don't remember what that form was, it was y equals mx plus b. And so m is slope and b is our y-intercept. We're going to look today at how we can use that equation to graph a line. And I know I already gave you an example last day, but we're going to go into more detail with it today. So when it comes to graphing lines, we have a couple different options. One is to make a table of values, or a table of ordered pairs. So if we're told that a line has a slope of -1/2, and it goes through the point -1, 5, we're going to use that -1, 5 to determine the rest of the points. So I have -1, 5, and again, my points are x and y. If I have a slope of -1/2, that negative goes with either the top, so the numerator, or the denominator. And so if it's -1/2, that would mean down 1. So down by a -1, or we move by a -1, and then right 2, because that's a +2. Or I can have a +1 and a -2, which would mean I would go up 1 and left 2. And so I can use those to determine some of my points. So if I have -1, 5, and I want to use a -1 and a +2, 5 minus 1 is 4, and -1 plus 2 is +1. So that would be a new point. I can subtract 1 again. So 4 minus 1 would be 3. 1 plus 2 is 3. 3 minus 1 is 2. And 3 plus 2 is 5. So those are some points. I again could go in the opposite direction as well. So if I had -1, 5, I could add 1 and subtract 2. And so 5 plus 1 would be 6, and -1 minus 2 would be -3. So that could also be another point, -3, 6. And so if I plot all those points, I would have -1, 5, 1, 2, 3, 4, 5, 1, 4, 3, 3, and so on. And we could verify that our slope works, because we should be going down 1, right 2, which we are, or up 1, left 2. And again, I would use a ruler here to connect my points. Let's see if it's a little more cooperative than it was the other day. So again, when you're drawing your graph, draw right through the Cartesian plane. All right, so I'll get you to try this one on your own. This one's actually, maybe I'll do this one with you. So here we've got 4x minus 3y equals 9. We're going to use a table. There's a couple different ways you can do this. You can rearrange your equation to begin with, or you can sub in values for x and then solve for y. If we leave the equation as is, so we've got 4x minus 3y equals 9, I can pick any value of x that I want. And so I like to start with the easiest one, and that would be 0. So 4 times 0 minus 3y equals 9. That would be 0 minus 3y equals 9. Divide by -3, divide by -3, and y would be -3. So one of my points would be 0 and -3. So I can do that. I can pick other numbers. So I can maybe pick 1. So 4 times 1 minus 3y equals 9. So 4 minus 3y equals 9. 9 minus 4 is 5. This isn't going to be a nice number, so I'm not going to bother. Let's maybe try 4 times 3. Let's try 4 times 3. So 4 times 3 minus 3y equals 9. So the other one would have given me a decimal, and those are hard to plot on there, so that's why I'm choosing a new number here. So 4 times 3 is 12, minus 3y equals 9. 9 minus 12 is -3. So I got -3y equals -3. If I divide by -3, y equals 1. So 3 was the x I chose, and that gave me a positive 1. Okay. So this is one way to do it. Another way to do it is to rearrange your equation. So I have 4x minus 3y equals 9. I'm going to have to subtract 4x from both sides. So I'm going to have negative 3y equals negative 4x plus 9. I'm going to divide by negative 3. And that gives me positive 4/3 x minus 3. And then from there I can choose numbers. So I would maybe choose to use a 6. So 4 divided by 3 times 6 is 8, minus 3 is 5. So if I chose to use a 6, I could get a 6 and a 5. If I chose to use 9, 4/3 times 9 minus 3, 4/3 times 9 minus 3 would be 9. So 9 and 9. So once I have those points again, I can plot. So 0, negative 3, 1, 2, 3, 3, comma 1, 6, comma 5, and 9, comma 9 would take me off or over top of these equations. And so 9, comma 9. And so again, I would be taking my ruler and connecting my points. So some of you might be asking, how are you getting those points? Where are you getting your x values from? I'm just making them up. I'm choosing numbers. Now, because this was 4/3, I was purposely choosing numbers that were divisible by 3, because you saw there when I tried one that wasn't divisible by 3, it gave me a decimal. So that was just me recognizing that when I have 4/3, I need numbers that'll divide by 3 in order to get rid of the fraction. Okay, but essentially what you're doing is you're just choosing random x values, subbing them in, and solving for y. I could have just as easily subbed in values for y and solved for x. Nevertheless, there's my equation. Now some of you are thinking, there's got to be an easier way. You showed us an easier way the other day, and there is. That's converting our equation to the slope-intercept form. And the only thing that can usually cause some challenges here is the rearranging of the equation. So if I've got negative 3x plus 2y equals 2, and we want to graph that equation, the first thing we have to do is rearrange the equation so that it's in y equals mx plus b. So I have negative 3x plus 2y equals 2. Ultimately, I need to get y by itself. So the first thing I'm going to do is add 3x to both sides. So I have 2y equals 3x plus 2. And then I want to get y by itself, so I'm going to divide by 2. And that gives me y equals 3 over 2x plus 1. Once we have that form, then we go back to what we did the other day. We find our slope, which is 3 over 2. And we find our y-intercept, which is 1. So our coordinate would be 0, 1. So the first thing we do is plot our y-intercept, 0, 1. And then we count our slope. 3 over 2 means up 3, right 2. Or it can also be written as negative 3 over negative 2, which would be down 3 and left 2. So up 3, 1, 2, 3, right 2, 1, 2, 3, right 2, and so on. 2, 3. So technically you only need 2 points to make a graph, but often 2 points isn't enough to make sure it's a nice graph if we're not holding our pencil evenly or whatnot. So I usually try to do a few dots just so it's easier to make sure I'm lined up. Okay, but ultimately the minimum amount you would need is 2 points on your graph. Uncooperative ruler. Wait a minute, don't I always tell you guys the calculator is only as smart as the user? So in this case, maybe the ruler is as smart as the user. All right, there we go. So just try a couple more practice questions just to make sure that you're comfortable. Again, my preference is, if I was doing this, I'm not a big fan of doing tables of values, so I'd probably go with the slope-intercept form. But both methods work, and one is a good check for the other. So if I've got 2x minus 4y equals negative 8, first thing I'm going to do is rearrange my equation. Subtract 2x, subtract 2x, gives me negative 4y equals negative 2x minus 8. Again, make sure you're paying attention to your symbols. It's very easy to lose a negative. Dividing by negative 4, I'm going to get y equals negative 2 over negative 4 is a positive 1 over 2x. Negative 8 over negative 4 is a positive 2. So my y-intercept is 2. And then my slope is 1 over 2. So up 1, right 2, up 1, right 2, or down 1, left 2, and so on. And again, take your ruler, and draw a straight line. All right, so there you have it. If you, oh, actually, no, there's one other thing I want to do. So if you needed some more practice, I'm not going to go through these examples, but I'll kind of talk you through them. If I had 2x plus 1, y equals 2x plus 1, I'd plot a point at 1 and then go up to right 1. If I had number 2, I'd have to rearrange my equation. Okay, again, you can use ordered pairs. The last thing I want to talk about is some special cases. So we are going to come across these equations that don't exactly look like y equals mx plus b. So for example, here I have x equals 4. Well, x equals 4 means no matter where I go on my line, x equals 4. So if I were to plot these points, if I were to plot all the places where x equals 4 here, x equals 4 here, x equals 4 here, and here, and here, and so on, I'm getting a vertical line. So any equation that says x equals a number is a vertical line. Now, if I have y plus 2 equals 0, I just need to rearrange that. Y equals negative 2. I'm subtracting 2 from both sides. And if I plot on my graph all the places where y equals negative 2, y equals negative 2 here, and here, and here, and over here. And so this is going to give me a horizontal line. So anywhere where y equals a number is a horizontal line. So you're going to come across these special cases every once in a while. That's just a couple examples. All right, that's it for tonight. We'll see you tomorrow. Make sure you ask questions if you need help. Have a good night.